Hello friends. So we'll be starting off with a branch of physics known as kinematics today. So basically kinematics is a motion or branch of physics where we are focusing only on the motion of particles or of objects and the trajectory that the particles or the objects are traversing or following. We are not concerned with the masses of the particles and the forces acting on those particles and other quantities or other things. We are only focusing on the mass on the motion of the particles and the path that the particles are following. Now there are a few basic concepts in kinematics. The most basic concept I would say about kinematics is the difference between distance and displacement. So for example, if there is a particle, say if there is a point say A and there is another point say B, and there is a particle which moves from A to B over a curved path, we can say that the distance traveled by this particle between point A and point B is equal to the total length of this curve between A and B. Whereas the displacement of the particle as it moves from A to B is the length of the straight line that connects A and B. So distance is a scalar quantity which has only a magnitude, whereas displacement is a vector quantity which has both a magnitude and a direction. So in this case, we know that since the particle has traveled from point A to point B, the magnitude of the displacement is the length of this line and the direction of displacement is this. For example, we can also take the example of a motion in a straight line. In this case, as a particle moves from a point say A to another point say A dash, the distance will be equal to the total length of the straight line that connects point A and B. And also the displacement will be equal to the length of the straight line that connects A and A dash. The reason being, this is a motion in a straight line. So in case the particle moves in a straight line, the distance is equal to displacement. And in case the particle does not move in a straight line, as in this case, the distance is always more than displacement. Distance is this, displacement will be this, so distance will be more than displacement. So overall we can say that distance will be either more than displacement or equal to displacement. So this is one thing. Now there is another very basic concept I would say, the concept of speed and velocity. Now the relationship between speed and velocity is the same as the relationship between distance and displacement, in the sense that speed is a scalar quantity with only a magnitude, whereas velocity is a vector quantity with both a magnitude and direction. So speed, we can say, will be given by distance traveled by time taken, whereas velocity, which we can represent as v, will be equal to change in displacement by time taken. Since velocity is a vector, we can denote this using the vector notation. So velocity is the rate of change of displacement with respect to time, and speed is the rate of change of distance with respect to time, or the distance traveled with respect to the time. So in this case, speed will be equal to this distance divided by the time taken for the particle to travel along this curved path from A to B, whereas velocity will be equal to displacement by the time taken for the particle to travel from A to B. So velocity, as I said, is a vector quantity, so it will have both a direction and a magnitude. So in this case, the direction of the velocity is like this only, same as the direction of the displacement. Now there is one very basic thing about this particular formula, in that it is not applicable for all cases. This formula will be applicable only for cases where the velocity over a certain duration of time is constant. And if the velocity is constant, only then this particular formula can be applied. Now let us go into this, try to understand this using the concept of ST graphs. We have an ST graph like this. The question is, what is an ST graph? ST graph is a graph where you are representing S, or displacement, along the y-axis and time along the x-axis. And the first and the foremost thing that we need to understand about any graph is that any graph has a parameter called slope, which is given by delta y by delta x. The slope of any graph will be equal to delta y by delta x. Now consider the case of a particle which is moving with a constant velocity. In that case, if you draw the ST graph of that particle, it will be like this. This line, it will be a straight line. It can also be a line like this. It can also be a line like this. or even this. So in this case, suppose we take a time interval, say t1, and another time interval, say t2. S1. S2. Now velocity will be S2 minus S1 divided by T2 minus T1. So in other words, velocity will be equal to this by this. This is S2 minus S1. This is T2 minus T1. So S2 minus S1 by T2 minus T1. That will be equal to the change of displacement by change in time. We already know that velocity is the change of displacement by change in time. So velocity will be equal to S2 minus S1 by T2 minus T1. Now S2 minus S1 by T2 minus T1. S2 minus S1 by T2 minus T1 will be also equal to delta y by delta x, because this is the change of y and this is the change of x. And what is the change of y divided by the change of x? The slope, right? So we can say that the slope of an ST graph is equal to the velocity of the particle. And in case the velocity of the particle is constant, the slope of the ST graph will be constant. And the slope of an ST graph being constant means that that graph is a straight line, right? If the graph is not a straight line, if it's a curved line, then the slope will be different at different time intervals, right? So that will be a different case. But in this case, we know that it's a straight line, the slope is constant at all times. So the velocity will be equal to change in s divided by change in t, and also this is applicable only if the velocity is a constant. Velocity is constant during the time interval. Now, in case the velocity is varying, how will be the ST graph? Suppose, let me draw the ST graph in case the velocity is continuously varying. It will be a curve. Now why will it be a curve? Because in case of a curve, this is not the only curve that's possible for a particle which has a continuously changing velocity. It can be any sort of curve, and the reason that it will be a curve is that curve a curve will have different slopes at different points, right? If you take this curve and if you take this point, it will have different slope. If you take this point, this will have a certain slope. And what is the slope at a point? Just draw the tangent to this particular curve at this point. The angle that that tangent will make with the horizontal axis, the tan of that angle is the slope of the curve at that point. So slope of the curve at this point will be the tan of the angle that this tangent to the curve at this point is making with the horizontal axis. Similarly, slope of the curve at this point will be equal to the angle that the tangent to the curve at this point is making with the horizontal axis. So this is an example of a particle, of an ST graph of particle with a continuously changing velocity. Now, whenever there is a particle with a continuously changing velocity, there are two important terms that we talk about. One is the mean velocity, or we can also call that average velocity. This will be equal to total distance traveled, or total displacement divided by total time. So in any numerical, suppose if you are asked to find out what is the mean velocity or what is the average velocity over a certain time duration, all that you need to do is calculate the total distance traveled by the particle during that time duration and then divide that by the total time duration, and you will get the mean velocity during that time duration. This is one thing, which is one very important thing that you talk about when you're talking about mean or average velocity. The other thing, or the other criteria, or in fact the other parameter that we talk about when we are talking about a particle with continuously varying velocity is V instantaneous. And V instantaneous is equal to ds by dt. Differentiation of s with respect to time. Right? And what is ds by dt? The rate of change of s with respect to time at any point. Right? So if you take the example of this curve, as I took 2 points, right? This is one point, this is another point. So at both these points, as I already said, the slope is different. Slope is the velocity, so the velocity is different. So the ds by dt at this point is different, is one thing, and ds by dt at this point is something else. The reason is s is changing with respect to time at this point at a different rate as compared to the rate at which s changes with respect to time at this time instance. So s is changing with respect to time at a different rate. So at two different time instances, the rate of change of s with respect to time will be different. And so because of that, the velocity at two different time instances is different, right? So what do we mean when we say instantaneous velocity? Simply put, velocity at an instant. So velocity at a certain time is the instantaneous velocity. Simple as that. Now let us come to a VT graph. A VT graph basically is a graph where the velocity is represented along the y-axis and the time is represented along the x-axis. Suppose if the VT graph of a particle is something like this. Time t1, time t2, suppose if you are trying to find out what is the total distance traveled by the particle between time t1 and time t2. That total distance will be given by the area under the VT graph between t equal to t1 and t equal to t2, this area. Also, if now we turn back our attention to this particular thing, as a consequence of this, what we can also say is that S is equal to integral of V dt between t1 and t2. So both this and this is the same thing. This is just the same concept being presented. Here it is being represented graphically. Here it is being represented in the terms of a mathematical equation. Okay. Now there is another important term which we call as acceleration. Acceleration is just rate of change of velocity with respect to time. Again, this will be applicable only if acceleration is constant during the entire time. If say during a time interval, time say between say some time instant say t1 and another time instant say t2, the acceleration is constant. What we can, if you want to find out, we know that the acceleration is constant between t1 and t2, but we don't know what is the value of that acceleration. We know the value of velocity at t1, we know the value of velocity at t2. What will be the value of acceleration? Delta v by delta t. So final velocity minus initial velocity divided by final time minus initial time. But this will be applicable only if the acceleration is constant throughout the time duration that we are talking about. If that is not the case, if it's a case where the acceleration is continuously varying, we have something like this, equal to d v by dt. Also now let's come to three main equations of kinematics which we use extensively in kinematics to solve problems, to understand situations and how fast a particle will travel with respect to time when it's thrown with a certain initial velocity and so on and so forth. So to understand all these situations of kinematics, there are three main equations which we use a lot. Here v is the final velocity, u is the initial velocity, a is the acceleration, t is the time duration interval, s is the displacement, u is the initial velocity, t is the time duration, a is the acceleration, t is the time duration. Here v is the final velocity, u is the initial velocity, a stands for acceleration, s stands for the displacement. So these are three main equations which we use quite a lot in kinematics, and they can be derived very easily actually. So if you take a look at the first one, it's very simple, it's quite self-explanatory. You already know that acceleration is equal to change in velocity divided by change in time. If the final velocity is v and the initial velocity is u and time duration is t, this change of velocity from u to v is happening over time t, then acceleration for this time duration t will be given by this. And if you just rearrange these terms, you will get v is equal to u plus at. Okay. Similarly, even these are very simple to derive. It's not a big deal. You can derive these equations by yourself. There is another term that you can use, or in that equation that you can use if you want, v plus u by 2 into time is equal to s. So if there is a particle with a certain initial velocity u and a final velocity v, and this change happens over a time t, then the total distance traveled by the particle over time t is equal to this, provided a is constant for this entire time duration interval. So you can easily derive these in this equation. I would recommend you that you should try to derive these equations, because that will help in increasing your understanding. Now let's come to a few problems. A point traversed of there is a particle which moves between a point A, say, and a point B, and there is a middle point C. This is D, and this is also is D. D is the distance between A and C. D is also the distance between C and B. So C is the middle point between A and B. A point traversed half the distance with velocity v naught. Half. D has travelled with velocity v naught. So say time from A to C is say t1 and time from C to B is say t2. So t1 is equal to d by v naught. V naught is the velocity with which it travels half the distance. So this distance is travelling with v naught. So d by v naught is equal to t1. The remaining part of the distance is travelled with v1 for half the time and v2 for other half. Now we have said that okay fine, let the time to travel from C to B be say t2. Now half the time, half of t2, sorry, t2, it travels with v1, and other half time it travels with v2. This will be equal to again d. What will be the value of t2? 2d by v1 plus v2. So what does v mean? Total distance traveled by total time. Total distance is 2d divided by total time, t1 plus t2. t1 is d by v0 plus 2d by v1 plus v2. d will get cut. So this is what you will get, 2 by 1 by v0 plus by v1 plus v2. You can slightly rearrange this term and you'll arrive at the actual answer, right? So this is one question. It's basically is for illustrating the concept of mean velocity or average velocity, right? I'm keeping this as an exercise for students. We just have to arrange this a little bit. v0 into v1 plus v2 will come up, 2 into v0 plus 2 v0 into v1 plus v2, then v1 plus v2 plus 2 v0 will be the denominator. You can rearrange these terms yourself. Second question. A car starts moving rectilinearly. Car starts moving rectilinearly with acceleration average velocity during that time is equal to 72 kilometers per hour. How long does the car move uniformly? Long does the car move uniformly? So basically the question is like this: car starts moving rectilinearly. Rectilinearly means in a straight line with acceleration w equal to 5 meter per second square. Initial velocity is 0. Then it moves uniformly for a certain time and then finally decelerates at the same rate. At the same rate means at 5 meters per second square, and then it comes to stop after some time. Total time of motion is equal to 25 seconds. Average velocity during that time is equal to 72 kilometers per hour. How long does the car move uniformly? Now we know that the average velocity is 72 kilometers per hour is equal to 72,000 per second. Average velocity is equal to 20 meters per second. Total time of motion is 25 seconds. So total distance traveled is 25 into 20, which is equal to 500 meters. If we can draw a graph of this particular car, VT graph, it will be initially the velocity of the car is 0, then it has an acceleration of something, it reaches certain value, it goes on at that velocity for a certain time, and then again it decelerates at the same rate. This is a VT graph. Now I can divide this entire motion from this time to this time into 3 parts. Suppose this is part 1, this is part 2, this is part 3. Now time taken for the part 1, if I want, say I consider this velocity as say v0. So say it starts off with velocity 0, reaches a velocity v0 at some acceleration which is equal to 5 meters per second square. So we can say that v0 is equal to u plus at. U is 0 here, a is 5 here, and t is this time. Let me apply the same equation here for this third part that I was talking about, where the car moves from this velocity v0 to velocity 0. If I do that, what will I get? Final velocity is 0, initial velocity is v0, plus minus 5t. v0 is equal to 5t. So this and this show that time taken by the car to accelerate from this to this and decelerate from this to this is the same. That's one thing. The second thing that I would like to draw your attention is that I've taken this as minus 5 because this is deceleration. The car decelerates from a speed of velocity of v0 to a velocity of 0. So this is deceleration. So that's why I've taken this value as minus 5. So this equation and this equation show that time will be the same. Time for the car to accelerate from a velocity of 0 to a velocity v0, and the time taken by the car to decelerate from a velocity of v0 to a velocity of 0 will be the same. So if this time we consider as t, this time also will be t. Let us suppose this time is t dash. So 2t plus t dash will be equal to total time of motion, which is 25. Right? T is the time that the car takes to reach from a velocity 0 to a velocity v0, and t is also the time which the car takes to reach from a velocity v0 to a velocity 0. So this is t, this is t, this is say t dash. So t plus t dash plus t is equal to 25. So 2t plus t dash is equal to 25. That's one thing. Now let us apply another equation to this part. say the first part, if I apply another equation, v square is equal to u square plus 2as, what will I get? V naught square is equal to 2 into 5 into s. Let me apply this equation to this part. V square, u is v naught square plus 2 into minus 5 into s. So again v naught square is equal to 2 into a into s. So this also shows that the distance traveled by the car from in this time and the distance traveled in this time is the same, right? So now how much is this distance traveled? S is equal to v naught square by 10. So distance traveled from here to here is the same as the distance traveled from here to here, and that is equal to v naught square by 10. V naught square by 10 plus v naught square by 10 plus distance traveled during this time will be equal to v naught into t dash. This will be equal to total distance traveled. Total distance traveled we have already calculated is equal to 500. V naught square by 5 plus v naught t dash is equal to 500. We know that v naught is equal to 5t. We can replace v naught here. V naught equal to 5t we can replace in this equation. We will get two equations. One is this. Both will have two variables t and t dash. So we have to use this equation and this equation. We have to solve this equation and we will get the values of t and t dash. I think it's fairly simple to solve these equations. I don't think I need to solve them in this video, but nevertheless, if anybody has any problem, you can notify me, you can inform me. I will solve these equations and I will create a separate video where I will be solving these equations. That's it for this video. Thank you.